First of all, thanks for being here in my YouTube channel, Geeta's UPSC Corner. So, friends, in this lesson, number 1 on the topic number system, we are going to learn introduction about it. So, before going on the topic number system, we can learn some of the important topics to remember number system. Okay. So, if you are going to any competitive exam, and for the campus interview questions or for UPSC or for SSC or for banking or for any other competitive exams, the number system topic is very, very important. And you might get at least one question from this topic. Okay. So before going to start my lecture, please do subscribe to my YouTube channel, Geeta's UPSC Corner. And also don't forget to hit the bell icon. So friends, as I told you, you might get some of the questions from this topic. So this is the important question in every competitive exam like banking and SSC, everything. So this number system will check candidate capability on handling the number, remembering the formula, and shortcut tricks application, everything. So this number system will check the capability of the candidate on handling the numbers. Okay. So before going to the brief introduction, let me tell you what are these numbers. Okay. So friends, the numbers here, I have given the classification of numbers. So before solving all those questions, you have to learn all those concepts, right? Only if you know the basic of number system, you can able to solve the question. So listen, friends, here in this video, I'm just going to teach you the easiest way to learn. So I'm just going to, I have drawn a chart here. Okay. So let me move on to the chart. So, so the numbers here, these are the numbers are divided into real numbers and imaginary numbers. Okay. So let me draw. So let us take 4 plus 3. So basically the numbers are divided into two categories. One is real number and the other is imaginary number. Okay. First, you need to know what is called as real number and what is known as imaginary number. So just see here, I have given example 4 plus 3i. Okay. You can take 7 plus 4i, everything, anything you can take. But here I have taken 4 plus 3i. So the letter I itself denotes imaginary number and the 4 here denotes real number. Okay. So this is the root I. Okay. This root I denotes imaginary number. So 4 plus 3i. So here again, these imaginary numbers, let us talk about it later. It is root I. Okay. First, let me tell you about the real number. Okay. You don't want to learn these imaginary number concepts in in this competitive exam. It is not necessary, that much necessary. So first, let us know about the real number. So this real number is further divided into rational number and irrational numbers, right? Okay. These irrational numbers are nothing but like root 2, root 5, root 7, like that. So these are all like irrational numbers. And rational numbers, so if we solve this root 2, it is like 1.414, 2, 3, like that. 1.414, so on. Okay. We know the value of root 9. Okay. So this root 9 is equal to 3. That is, it is rational number only. Okay. So these irrational numbers are also known as surds. This I will explain you in the later section. Okay. This one, if these irrational numbers are solved, we get in the decimal format. Okay. So rational numbers. These rational numbers are separated into two categories, integers and fractions. Okay. So the numbers in the real numbers are categorized into two types, that is rational numbers and irrational numbers. Again, the rational numbers are divided into two types, that is integers and fractions. So fractions you might know 3/4, comma 1/2, comma 5/2, so on. Okay. So these are the examples of fractions. And integers, normal integers. Integers are again divided into, integers are like minus 99, let me annotate. Minus 99, minus 98, comma minus 97, comma minus 96, so on, like that. So on, minus 3, comma minus 2, comma minus 1, comma 0, comma 1, comma 2, comma 3, so on, 98, comma 99, comma 100, comma so on, infinity. Okay. So this was all the integers. Okay. So the integers are divided into, these are further divided into positive integers and negative integers and 0. As I have said, minus 98, minus 790, minus infinity to minus 1 is known as negative integers, and 0 itself here will include in integer. And again, from 1 to infinity will be positive integers. Okay. So again, these positive integers are further divided into even number, odd number, prime numbers, and composite numbers. Okay. So natural numbers are like 1, comma 2, comma 3, comma. Okay. One comma 2, comma 3, comma so on, infinity. Okay. So these are natural numbers. So coming to whole numbers, if we include 0 to natural numbers 0, 1, 2, 3, 4, 5, so on infinity. These are whole numbers, right? These are whole numbers. So let me explain again. So the numbers, we have to see the numbers here are divided into two types. One is the real number and imaginary numbers. Coming to real numbers, the real numbers are further divided into rational numbers and irrational numbers. Okay. So irrational numbers are like root 2, root 5, root 7, and again root 11, like that. So rational numbers are nothing but those numbers that have integers and fractions within themselves. Okay. So the integers and fractions are known as rational numbers. These integers are again further divided into positive integers, negative integers, and zero. And the positive integers are divided into even numbers, odd numbers, prime numbers, and composite numbers. And positive numbers are divided into natural numbers and whole numbers. So these natural numbers are further divided into four types, which are sorry, I have given only four types which are important for the quantitative point of view. I have also explained in the next later slides. These four are important for the any competitive exam. If you take these four, these are the most important for the competitive exams. Okay. So I have given other numbers also in the other slides. Okay. So even numbers. Let us see what is a even number. Okay. These even numbers, which the number which is divided by 2, okay, are known as even number. Let us take the example x by 2. So let us take example 4 by 2. 4 by 2. That is 2. This 4 is divided by 2. So the 2 is even number. If we take the number 104, it will be divided by 2 52 times. So this 104 is also known as even number. If we take any number, let us take number 77. If this 77 is not divided by 2, then this number 77 is known as odd number. Okay. If a number is not divisible by 2, then the number is known as odd number. Okay. Let us see what is prime number. The prime number, the number which has factors 1 and itself. Let us take number 11. Okay. This number is divisible by 1 and the number 11. Okay. So this 11 is prime number. And 7, 2, 3, 5, 7. All these are prime numbers. Okay. Let us see what is composite number. Composite numbers are those numbers which are not, which have more than 2 factors. Okay. If a number has more than 2 factors, it is known as composite number. If we take number 8, this number 8 has factors like 1, 2, 4, and 8. Okay. These numbers are known as factors of 8. Okay. So the number 8 is known as composite number. Okay. Okay. So this was the basic understanding of number system, the classification of numbers. I will further explain some other numbers in other later slides. But these numbers, even number, odd number, prime number, whole number, natural number, integer, rational number, irrational number, fractions, these are most important for competitive exam point of view. But there are other numbers also which are important in number series part, which I will explain in the later slides. Okay. So coming to the next slide. So here the number system is divided into, I have already told you, I have included the topics which we will be learning in the number system part. So the number system here we will be learning about classification and also divisibility test, division and remainder rules, sum rules, unit digit, everything here in the number system only. Okay. So let us see the classification of, let us briefly understand what is the classification of numbers. Okay. So natural numbers. The numbers 1, 2, 3, 4 are called natural numbers or positive numbers. Okay. Whole numbers. Whole numbers, I had told you, whole numbers include 0. So the numbers starting from 0 to infinity are known as whole numbers. Coming to integers, this minus infinity to plus infinity, that means minus infinity to so on, minus 99, minus 98, minus 97, so on, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on, 99, 100, and so on, and infinity. So these will be integers. Integers will include negative integers, positive integers, and 0. Okay, the negative integers will come from minus infinity to minus 1, whereas the positive integers will start from 1 to infinity. Okay, so you will be seeing more questions on integers in all the exams. Okay, as I told you, negative integers are nothing but from minus 1 to minus infinity. Okay, the positive fractions, as you know, 2 by 3, 4 by 5, 7 by 8, everything are fractions which are in the a by b format, are known as fractions, where b is not equal to 0. If we keep b equal to 0, the number will be we get in the form of infinity. Okay, we cannot divide it if b is equal to 0. Okay, if we keep a by b, a equal to 0, then the obviously the result will be 0. But if we keep b equal to 0 in a by b format, we cannot divide it. So we always tell fractions are nothing but a by b format, where b is not equal to 0. Okay, and next coming to negative fractions, minus 6 by 8, minus 7 by 9, minus 12 by 17, etc., etc. Those are negative fractions. Okay, so rational numbers. So rational numbers, let us see, any number which is a positive or negative integer or fraction or 0 is called a rational number. As I told you, positive integer, negative integer, fractions, 0, everything is rational number. Rational number is one which can be expressed in the a by b format, where a and b equal to not 0, and a and b are positive or negative integers. A and b might be positive or negative, but b cannot be 0 in rational number. Okay. Irrational number. Irrational numbers are numbers that have a recurring decimal number. That means if we take example root 2, okay, equal to 1.2 4, 1, 4, so on. Non-recurring. Okay. We get some 1.4, 1, 2, 3, 8, 6 like that. So we get non-recurring, infinite. We get infinite decimal. Okay. So this infinite decimal non-recurring number is known as irrational number. That means root 2, root 5, pi. The value of pi is 22/7. Okay. So these are all irrational numbers. If we take surd, surd means any root of a number which cannot be exactly found is called as surd. Okay. Essentially, all surds are irrational number. Example, root 2, root 5, all these are irrational number. Okay. So these are the basic, as I already told you in the previous slide. So this was the basic overview of the classification. Let us see another slide. From in the another slide, I have took the consecutive numbers. Consecutive numbers. What are the consecutive numbers? Consecutive numbers are the numbers arranged in increasing order, differing by 1 or 2 or 3 or so on like that. Okay. If we take x plus 3, comma x plus 6, comma x plus 9, so on, those are also known as consecutive numbers. If we keep x equal to 3 in the that format, we get the series will be like 3 comma 6 comma 9 comma 12 comma 15 comma so on. So those are also known as consecutive numbers. Okay. So the consecutive numbers are arranged in increasing order, differing by, it might be 1 comma 1 2 3 so on. Okay. Those are known as consecutive numbers arranged in increasing order. Okay. Okay. Next, coming to the next one, the real numbers which I have told you in the previous slides, the rational numbers, irrational numbers, integers, whole numbers, natural numbers, everything will constitute the set of the real number. Okay. Every real number can be represented by a point on a number line. Okay. We can represent in the number line. The real numbers can be represented on a number line. Okay. Perfect numbers. Let us see the what are perfect numbers. Let us say, if the sum of all the factors of a number, excluding the number itself, happens to be equal to the number, then the number is called a perfect number. If example, I have taken a number 6. If this number factors are 1, 2, 3, and 6, this number is excluded, and these remaining factors, these numbers are summed. If we sum these 3 numbers, remaining numbers, 1 plus 2 plus 3, if these numbers are equal to the number factors of a number, these factors of a number sum, the sum of all the factors and the number excluding the number is equal to the this number. Then this 1 plus 2 plus 3 equal to 6. So this number is known as perfect number. Okay. This number is perfect number. If we take the number 28, 1, the factors will be 1 comma 2 comma 14, 4 comma 7, and 28. Let us see what are the, if 28, excluding 28, if we get sum of all those numbers, again 28. The 28 will be perfect number. 1 plus 2 2 plus 4 plus 7 plus 14. Okay, that's it. 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14 is 28. So, 28, this is 28, and the sum is also 28. The remaining factors excluding the number itself, those sum is also equal to 28. Okay, so this is also perfect number. And also we get the other perfect numbers like 496, 8128, etc., etc. So these are perfect numbers. Okay. Complex number. Complex number is like 2 plus root 3, 2 plus 2 minus root 3. Okay. 2 plus root of minus 3. Okay. These are like complex numbers. See, 2 plus root of minus 3. We cannot find the square root of a negative number. Okay. In reality, we don't have square root of negative numbers. Okay. So such numbers are called imaginary numbers. Okay. See, this Fibonacci numbers, these Fibonacci numbers are those numbers which are added, obtained by sum of the preceding two numbers. Okay. If we take 1 plus 1, wait. 1 plus 1 is equal to 2. I have taken example like 1 comma 1 comma 2 comma 3 comma 5 comma 8 comma 13 comma 21, so on. Okay. So 1 plus 1 is equal to 2, 1 plus 2 equal to 3, and 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, 5 plus 8 equal to 13, 8 plus 13 equal to 21, and 13 plus 21 is equal to, we get 4 and 3, 34. The next number will be 34. These are known as Fibonacci numbers. Okay, Fibonacci numbers. These are obtained by adding the sum of the preceding two numbers. Okay, previous two numbers, sum will be the next number. So these series are most important in these are most important in number series concept. Okay. And the next one is even number. even number. Sorry, this slide has gone upwards. So I have given odd number, even number, prime number like that. So let us take even number. The integers which are divisible by 2 are known as even numbers. Okay. Don't mind, friends. This was gone upwards. So I have given in the upward part, we have even number. We are discussing about even number. The integers which are not which are divisible by 2 are known as even numbers. I have given no examples 2 comma 16, 4 comma 8 comma 2 comma 16, etc., etc. These are even numbers. So coming to odd numbers, the integers which are not divisible by 2. Okay, the integers which are not divisible by 2 are known as odd numbers. Example 7 comma 15 comma 5 comma minus 9, etc., etc. Okay, coming to prime number, I have already told you those numbers which are divisible by only themselves and 1 are known as prime number. Okay, in other words, prime number have only 2 factors, the number 1 and itself. Example 2 comma 3 comma 5 comma 7 comma 11, 13, okay, etc., etc. See, here note the number 2 is only even prime number, only even prime number. Okay. Co-prime numbers. Co-prime numbers are numbers, two numbers considered to be co-prime if their highest common factors are 1. If the numbers have, the both numbers have a highest common factor, that means HCF. If the GCD or HCF is 1, those numbers are known as co-prime numbers. For example, I have taken 5 and 24. These numbers are co-prime numbers. Okay. Okay. So coming to the next part, that means um, whether we have to check number is prime or not, we have to take the number. If that number we have to take that number and we have to check the preceding square roots of the numbers. Okay. That means 79. The 79 is the closest to 81. Okay. 81. 9 squares. We have to check the squares. Okay. The 79 is closest to 81. Okay. And 79 is also closest to 64. Okay. So we have to okay, we have to check the previous one and the next one. Okay, this was in between 9 and 8. So we will be checking, taking the factors less than 9 only. Okay, so the factors less than, the prime numbers less than 9 are, so the 9 is a factor of 79, right? Check if any of the prime numbers less than 9 is a factor of 79. So we will be taking for the prime numbers less than 9. So 2 comma 3 comma 5 comma 7. So if we check the prime numbers, these prime numbers are divisible by 7 or not, 79 or not. So if these any of these numbers are divisible, then that number is not a prime number. If any of the numbers are not divisible, then it is a prime number. So here 79, the prime numbers 2 comma 3 comma 5 comma 7, those any of the number is not divisible by 79. Okay, the number 79 is not divisible by any of the prime numbers below 9. So this 79 is a prime number. Okay, so this was the concept. We have to check whether a number is prime or not. Okay, so the next part is composite number. I have already told you composite numbers are not those numbers that are divisible by number other than 1 and the number itself. The numbers which are not a prime are known as composite numbers itself. Okay, Composite numbers are the inverse of a prime numbers. A composite number, on the other hand, can be any whole number that has more than two factors. I have already told you know, if the number has more than two factors, then the number is known as composite number. For example, if we take a number 8, the number 8 will have a, how many factors? 1 8s are 8. Here we have two factors. Two 4s are 8. So we have four factors. So we have four factors. So the number 8 is known as composite number. So the composite number can be even number or odd number. Okay. So note. So I have given a note point. Here one is not one is not a prime number, not a composite number. So we say that one is neither a prime nor composite. Okay. So examples of composite number are 9, 16, 25, so on. Okay. So let us see the operations on odd and even number. If an addition or subtraction of any two odd numbers will result in an even number or zero. Okay. See, if we take addition of two odd numbers, 2 plus 5 equal to 7, 11 minus 5 equal to 6. If we take addition of any two odd numbers or subtraction of two odd numbers. See, here I have taken 2. It is not 2. I have to take 3. But I have mistaken. So 3 plus 5 equal to 8. We will get an even number. 11 minus 5 equal to 6. Okay. 3 plus 5 equal to 8. 11 minus 5 equal to 6. Okay. In any addition of two odd or subtraction of two odd numbers will result in even number. Okay. Addition or subtraction of any two even numbers will always result in even number or 0. I have told you, 6 plus 8 equal to 14. Two even numbers addition and two even numbers subtraction will always result in even number only. And addition and subtraction of two odd numbers will also result in even number only. Okay. Let us see the next point. Addition or subtraction of an odd number from an even number will result in odd number. If we take a number 8, 8 is an even number and 5 is an odd number. If we add these two numbers, we will get an odd number. And if we subtract 8 minus 5, we will get 3. So this was also odd number. So addition or subtraction of two even numbers will always result in odd number. Next, addition or subtraction of an even number from an odd number will also result in odd number. The same thing we have flipped here. First we have taken odd number and even number. Here we have taken even number and odd number. Okay. So multiplication of two odd numbers will always result in odd numbers. So 5 into 7 is 35. 1 into 5 is 5. 5 into 3 is 15. Like that. Okay. So two odd numbers will, if multiplied, we get odd number. And two even numbers, if multiplied, we get only even number. Okay. If we multiply 4 into 4, we get 16 only. We get even number only, not an odd number. So multiplication of an odd number and an even number will result in an even number. Okay. This was the basic thing. Okay. So guys, thank you so much for watching. I hope you all like the session and thank you so much. Keep supporting me and let's meet in the next lecture. Thank you so much, guys.